Hey, what's going on guys, TurtyWurty here, and welcome back to another Minecraft modding tutorial for Forge 1.17. In this tutorial we are going to go ahead and cover packets. So this is a continuation of our keybind tutorial and also a continuation of our block entity tutorial. So we want to make it so that when we sit on the toilet we are able to press a key and it will fart. So let's get straight into it. So to do this we are going to be using packets, as I have said. Now if you don't know what packets are, it's basically a way of syncing data between the client and the server. It works either way. You can send one to the client from the server, or you can send one to the server from the client. And yeah, you can save data in the packet and transfer data, or you can just do something when the packet arrives. We will actually be saving data and doing something when the packet arrives, and we're going to be creating two packets. One will go to the server and the other one will come back from the server to the client. So let's get started. Let's first go into our client. No, let's actually create the packets first. So let's go into our init package. Let's create a new class called packet. I'm going to call this packet handler. Packet init is just a pain to say and everything, so we can make this a final and once again a private constructor like all our init classes. In here, let's first create the public static void init. Now, we don't register packets like everything else. These do not go on the deferred registry. We have to use something called a simple channel, and this is basically the channel that the packets are sent there. So let's create this simple channel. So let's come here, let's create a public static final simple channel, and I'm going to call this instance is equal to network registry dot new simple channel. This first takes in the name of the channel as a resource location, so let's go a new resource location. First will be our mod ID, so tutorial mod.mod ID, and then this is the actual name of the channel. So if you only have one channel, which you probably will, we'll just put main. Then it wants a supplier of the protocol version. Protocol versions are slightly strange, but essentially it is a way of differentiating the side that it happens on and the different protocols. It's a little bit confusing. You should probably only ever need one protocol version, so that will just be a supplier of. And now let's create this protocol version. So this is just a private static final string protocol underscore version is equal, and it's simply just one, but as a string. Okay, now let's come over here to our supplier. Let's just put a semicolon on the end so that we can format. So it's just a supplier of protocol version. Then we have the client accepted versions and the server accepted versions, and these are predicates. So these are basically the protocol versions that the client and server will accept. So since we want to be able to accept both of them, we just want to be able to do protocol version : equals, and once again protocol version : equals. And that's probably what you'll ever need. It's unlikely you'll ever need anything more complex than that. So let's come into our init method. In here we're first going to create an index. Int index is equal 0. And now let's go ahead and register a packet. So let's do instance. First we'll go ahead and do the client to server packet. So let's go instance.messageBuilder. This first takes in our packets class, which I haven't created yet. However, I have already come up with a name for it. So since this is a client to server, this will be called a server bound toilet update packet. A little bit long of a name, but that's just how it is. And then .class, since it wants the actual class. Then for the index or the ID, we can just do index++. And then we need the network direction, and this is basically to ensure that the packet can only go in one direction. The direction we want it to be able to go into is network direction .play to server. Now you'll see there's 4 different network directions here. There is login to client, there is login to server, play to client, and play to server. Now these login ones, you can basically ignore those. These are for internal sort of forge stuff. Basically what they do is this happens whilst the packet is being sent, essentially, or whilst the handshake is being made, and these play to client and play to server happen when it is already happened, when the handshake has been accepted, basically. So play to client is basically server to client, and play to server is client to server, and these are the only 2 you will need. You can ignore the login ones completely. So we want play to server. There we go. And now we need to set the encoder, the decoder, and the consumer. So let's do .encoder. And this will take in our packet class, encode. Actually, let's leave this out for a second. I will come back to this. We'll just call .add on the end. Add. There we go. That's fine. That's obviously going to give us an error because this class doesn't exist. So let's go ahead and create this class. So in our core package, I've already created a package for .network. You can also call this .packets. That's fine too. .network just makes a little more sense to me personally. And we want to create a new class in here for our packet. So that will be the server bound toilet update packet. Okay. And in here we're going to need a constructor, and this is going to take in any of the data that you want to save. So I want to be saving a block state, a block pos. I want to pass through a block pos, and I want to save that so that I can then use that block pos to grab our block entity. Obviously you can save whatever you want as long as you can write it to a friendly byte buffer, which is basically just MBT. It's fancy MBT basically. So let's create a field for this. That'll be a public final block pos, and I'll just call this toilet pos. Okay, we also need to import that, and let's just initialize it. So this .toilet pos is equal toilet pos. Oops. Oh, I just called it pos. That's why. There we go. Now let's first create the encode method. So encoding is basically saving it to the MBT or to the buffer. So we can go public void encode, and this takes in a friendly byte buffer, and we'll just call that buffer. And then we can simply just do buffer.write, and then you have all these different possible write methods of the things that you can write to it. The thing I want to write, I mean, you can write everything. You can write items, item stacks, fluid stacks, all these different things. You can write custom ones since you have bytes here. But I'm going to be writing a block pos, and that just takes in the toilet pos. Then we're going to want to decode. Now, you have two options for decode. You can either make a public and then server bound toilet update packet, so the name of your class, decode, and that could take in a friendly byte buffer, and you could simply do this.toiletpos is equal buffer.read blockpos, and you need to, well, I guess you can actually do return a new server bound toilet update packet buffer.read blockpos. So you could do this, however that doesn't really make much sense to me, since all you're doing is constructing a new packet and you've created a method for it. So what I prefer to do is get rid of this decode, turn this into a constructor, and just instead of returning a new packet, just call this. So that will allow it to be passed through to here, and it will just be set normally. That's what I prefer to do. I think that's much simpler. And the final method we need is the handle method. So this is when the packet is received. So this can be a public boolean. It can be void if you want, but I'm just going to do boolean. And we'll call this handle. And this will take in a supplier of network event dot context. And I'll just call this CTX. Okay. Let's import supplier. In here, I'm first going to create an atomic boolean, and that'll be for whether basically it succeeds or not. So let's do var success is equal to a new atomic boolean false. Okay, and then we can do ctx.get.enquework. And here we have a runnable, and here is where you do all your stuff. So let's first, okay, no, we don't really need to get the context. Let's try to get the block entity. So block entity is equal to context.get.sender. So that's the server player dot level. So we now have the world, and then we can just do get block entity toilet pods. Now you need to make sure you actually need to be really careful here. So since this packet will arrive on the server, it's fine for us to use this context because this context has the server player. This is fine. But if this was on the client, so if this packet was being sent from the server to the client, we cannot use this sender because this sender is for the server player only. And I believe that's the same with actually a lot of these things. Actually, no, the other things are fine. It's just the get sender. So obviously, if you're on the client side, actually, I can show you that later because we'll be doing a client packet too. But yeah. Just make sure you're doing this on the correct side. And then we can just say if block entity is instance of, and then we can check if it's our toilet block entity. We'll just call that toilet using some good old pattern matching. We can literally just say toilet.is shitting, and we just do our logic here basically. So I just want to basically set everything, and then we can just set success to true, since at that point it's worked. So here you just handle any of the logic you want to handle, and this will be on the server toilet block entity. And finally, we just need to do context.get.set packet handled, and we need to set that to true, so it now knows the packet has been correctly handled. And then we can just return success.get. There we go. Now we can come back into our packet handler and we can finish this off. So we need to add the encoder, and we can just do server bound toilet update packets encode. And then we need to do the decoder. So let's do .decoder server bound toilet update packets new. Or if we had our decoder method, we would just use decode. But since we used the constructor instead, we can just do new. And then the consumer will be our packets handle. There we go. Now obviously you don't need to call these methods exactly what I've called them. You can call them whatever you want as long as it makes sense to you. You can call encode, you could just call that save if you wanted to. And if you're using this as a method instead, you could just do something like, you could have void load if you wanted to. Constructor just makes more sense to me, and I don't want to call this save. There we go. Okay, so that is our first packet. Let's go ahead and send this, shall we? So let's come into our client tick event, and as you can see here, we have the set shitting. I'm going to come into here, and you'll see I have a to do for sending the packet. So let's remove this to do, and we need to send this packet to the server. So all we do is call packet handler dot instance dot send to server, and we can do a new server bound key press. Wait, I didn't call it that, did I? What did I call it? I called it toilet update packet. Right, yes. And that just takes in this world position. Okay. Now, as you can see here, we have a to-do for sending the client packet. So I've just put some code in here for what happens when the key is pressed, basically. Whatever logic you do is completely up to you. It's just the logic I want to do alongside it so that I can demonstrate the packet correctly working. So we need to send a new packet here. So let's go packet handler. If I did it correctly, there we go, packet handler.instance. And we want to send it to the client this time. And we want to send it back. So we're going to do send, and then it takes in a packet target. So since I'm sending it to the client, it doesn't really matter what I use as the target. So it's packet distributor. I'm just going to use tracking chunk, since I want to send it to the chunk itself. We could send it to the player. No, player is server player, so we can't send it to the player. Yeah, we'll just use tracking chunk, and then we can use .with, and then that needs to take in a supplier of the chunk. So to get the chunk, we can just use this .level .get chunk, and that can just take in the world position. And then it just needs the packet that we want to send. So I want to send a client bound packet. So let's go client bound update toilet packet this .world position. Now obviously this packet doesn't exist, so I can create it. So if my Eclipse wants to load, there we go. Let's create a new class, a client bound update toilet packet. Okay, and once again, in fact, I'm just going to actually copy the server bound one, since it's going to be very, very similar. Make sure I copy it correctly. Now all we need to do is change these things to client bound. We still want to save the block pos, and here we can do things slightly differently. So let's get rid of that. Okay, so we have our basic client bound packet. Now here is when we want to do things slightly differently, because since this packet is being sent to the client, everything inside of this in-queue work needs to be client only. And if we just write some client code in here, that might not work, because we're constructing this packet. If you come into our tile entity, or our block entity I mean, you can see that we are constructing our packets down here on the server side. So this sort of gives us an issue, because we can't use any client-side code in here. Otherwise, it's not going to work on the server. So what we have to do is we have to use the dist executor. So let's go dist executor, and then we use the method unsafe run when unsafe run when on, that's the one, and we're going to run this on dist.client. And what we need to do is we need to have a supplier of a runnable, I believe, and then of the stuff that we need to do. So we're going to do success.set, and I'm going to set this to client access dot update toilets and the toilet pos. So let's explain what we're doing here. So when the in-queue works happens, so when this happens, we have the dist executor. Now when it's on the client side, it does a run. Now this takes in a supplier, right, so that it's not called straight away, of a runnable. And when it runs, we want to set the success to true, or whatever comes out of here, using our client access. Now I haven't created this client access in this tutorial, but I will show you what it is. So essentially we want to make sure, as I was saying, everything is loaded on the correct side, and the way we do that is creating a client access that we can access safely. So if we come into our client access, in here I've created the method which will just update the toilet. And the reason this is in client access is because we have to use Minecraft.getInstance. Anytime you need to use the Minecraft class, that is client only. So you need to make sure you access it only in a client area. This is a very important thing to get right. If you get this wrong, your mod will not work on the server. So yeah, very important. In here we just return false if it didn't work and true if it did work. And obviously that is just passed to this success.set. That's the only way we can get this success out of here and to return. So yeah, I hope that's not too complicated. It might be a little complicated at first to understand, but eventually you'll get the hang of it. You'll understand what's going on here. So yeah, that's pretty much it. Let's come into our toilet block entity, make sure that's sent correctly. Should be. Okay, now let's go ahead and register that client bound packet. So in our init, we just want to do another instance dot message builder, and this time it takes in the client bound update toilet packet dot class. I'm just going to copy this class name, we're going to need it. Once again, index ++, and this time it's going to be network direction dot play to client, since this is a client bound packet. Then we can do the encoder, and we want to just call encode then the decoder, where we can just call the constructor. Then we have the consumer, which is the handle method, pretty much. And then we just call add, which adds it to the channel. The final thing we need to go ahead and do is make sure we call this init method, which is very simple to do. We just need to come into our core events, into our common mod events, and in common setup we can simply just call event.enquework, and that can be packet handler : init, and import packet handler. That should be it. I don't think I forgot anything. No, it should be fine. Let's go ahead and run the game, and we can hope that it works. Here we are in the game, and here is the toilet. So if I come and sit on it, that's all fine, all well and good. Now if I just check my keybind key, what was the keybind key? It was S. So if I press S, it plays the sound and it ejects me off it a few seconds later. And you should be able to see, if I press S multiple times, it only plays once. So that is just the logic that I did in my block entity. So yeah, obviously that wouldn't work normally, because playing a sound to the world it doesn't work client side. But since we made a packet, we have allowed that to be sent to the server and have the logic happen there. Hopefully I will be able to better demonstrate this in the next episode, where I will be covering block entity renderers. Maybe that'll be next. We'll have to see about that. I'm not too sure yet. But yeah, I hope you guys did find this tutorial useful. Obviously, packets aren't just for block entities and toilets. They are very useful for GUIs and all those different things. But yeah, I hope you guys did find this tutorial useful. If you did, please do be sure to touch that like button and subscribe as well. If you really enjoyed, please do be sure to share it. And yeah, I will see you guys in the next tutorial. Goodbye.
3 of the hardest things for people to say: I was wrong, I need help, and Worcestershire sauce. Worcestershire.